Okay. I give us question 3. You answer in the comment section. Question 4. We have a stone is thrown vertically upward. Okay, from a point which is 3 meters above the ground with speed 60 meters per second. Find A, the time of flight, of the stone. Okay, B, the total distance traveled by the stone. Let's allow people to come in, and we'll see the solution to the question. Okay, please begin to call your friends from different quarters. Call your friends to join this live section. Okay, and begin to share the links of this video across your different platforms. Share the links on WhatsApp, share the links on your Facebook, on Twitter. Begin to share the links of this video across different platforms. If you are fresh on this channel, subscribe right now. Please subscribe right now. 3 meters above the ground. Let's say this is the ground surface. So 3 meters above the ground. So this is my 3 meter from here to here. Okay, that's a 3 meter. So from here, a stone is what? Is thrown. A stone is thrown vertically upward with a speed of 16 meters per second. With this speed. Okay, so it's going to follow these paths. Okay, it's going to follow that path. Okay, so this is the ground surface. Okay, so this will be this is parabolic in nature. So this will be the maximum height. That's the maximum height. That's the maximum height. Okay, vertically upward, acceleration is minus g. Okay, the speed u is 16. U is 16. Okay, what again we need? Want to find the time of flight. Time of flight. Time of flight is a if you get the time to reach the maximum height, okay, then time of flight is 2 times the time to reach the maximum height. So it's just the time that it takes from the point of projection to the what? To the horizontal surface. Time it takes from here to the what? To this place. That's the time of flight. So let's quickly apply the parameters we have. We have u, we have acceleration, we have t. We can use this equation. S equal to ut plus the half at squared. Okay, we can use that. We can use that equation. So our distance, we have distance also. X is 3 meters, but this distance is going to be minus because we are going to take positive this one. This one is just below the point of projection, so it's going to be negative. It's below the point of projection, so that will be minus 3 meters. So that's the distance is minus 3 meter because it's below the point of projection. Okay, take the upward direction as positive. Okay, so that will be minus 3 equal to my u is what? 16t, 16 times t. Then my acceleration is minus, that's minus g, times 9.8, and then times t squared. Okay, then we can have 16t half times 9.8, that's 4.9 t squared. Okay, minus 3. Then this quadratic equation, this has formed quadratic equation, so we can move everything to one side. We can move all the parameters to one side. Move this one to the other side. That's 4.9 t squared. This one also to the other side, minus 16 t, and then this one is already here at minus 3 equal to 0. So that's what we have. Then, because of this decimal, you can factorize it. So you can use your quadratic formula. Okay, so whereby your A is 4.9, your B is what? Minus 16. Your C is minus 3. Okay, so with that now, you can use the equation, the functions of t. So t is equal to minus b plus or minus b squared minus 4ac over 2a. B squared minus 4ac over 2a. So make your substitution. Your b is minus 16. That will be 16 plus or minus, okay, b squared. I think that's 256 minus 4 times a. My a is 9. My a is 4.9. My a is 4.9 times my c is minus 3 over 2a. 2 times 4.9. 2 times 4.9. Just take a calculator. Let's get that. So your t will be equal to 16 plus or minus. This one minus that's plus. That will give you 844. 844 over 2 times 4.9, approximately 4.7. 4.7 seconds. 4.7 seconds. So that's that on that question. That's that on that question. 4.7 seconds. Okay. 4.7. That's the time of light. Okay. That's the time of light. Okay. That's the time it takes to come back to the projection plane. Okay. That's the number of time of light. Time it takes to come back to the projection plane, or 2 times the time to reach the maximum height. Distance is 3 meter. The total distance traveled. Okay, distance is 3 meter. A is minus g. That's minus 9.8. What again we have there? We have the speed. U is 16. Okay, so what we're going to do is to, at maximum height, at the peak here, at the maximum height, the v is 0. The final velocity is 0. So v is 0, g is 16. Okay, so we can use this equation. And that will be equal to what? V squared, that's 0. My u is 16 squared. A is minus g, that's minus 2 times 9.8. And that's my distance. I can get this distance. So that will be the distance to get to the peak of the projection. That's the distance to get to the peak of the projection. Equal to what? Equal to 16,256. 256. So distance is equal to what? 16 squared, that's 256 over 19.6. So calculator. What we are going to do now is to, this distance is just the distance it takes to get to the peak of the motion. So the distance, the total distance traveled, okay, by the stone is equal to, okay, 2 times the height to the peak, 2 times this one, okay, 2 times this, and then plus the 3 here below the point of projection, the 3 here below the point of projection, okay, because if you project this one, okay, so you are saying up to this point, this one, that's the height to the peak, okay, so times 2 to get here, and then plus the one below the point of projection, so plus 3, plus 3, plus 3, then we have calculator also do that, and then you get your answer. That's 29 29.06 meter. So that's total distance traveled by the stone. That's the total distance that traveled by the stone. Okay, so let's see another question. Ball is released from rest. Okay, underline this from rest. When an object is released from rest at a point which is 10 meter above a wooden floor. So let's say this is a wooden floor, okay, which is 10 meter above a wooden floor. So 10 meter above the wooden floor. So that's a 10 meter from here. That's 10 meter. Okay. So if it's released, it's going to follow this take this pattern and go down that way. With release, with the peak, that's the peak point, or the highest point. That's the peak point. Okay, and preliminarily you must know that at the maximum height, d is 0. Okay, and when you drop an object from the height, your u is what? Your u is 0. Okay, so we have this x is at 10 meter. Each time the ball strikes the floor, it rebounds with 3/4 of the speed with which it strikes the floor. Okay, so let's u1 be the what? Be this speed at which it strikes the floor, and then g acceleration is what? Vertically downward. That's a plus g. That's my acceleration. That's a plus g. Okay, that's plus g. What again we have? So we need to get the u1, the speed at which it strike the floor. We can use this equation. When you drop an object from the height, u is 0. So this is my u1, 0 plus 2 times 9.8, and then times 10. Okay, this one, my u is 0. This one, that's the speed at which it strikes the ground. So that will be u1 square. So u1 is equal to the square root of what? This will be 98 times 2. That's 14. So that's our speed at which it strikes the ground. u1 is at 14 meters per second. That's the speed at which it strikes the ground. Then we are told find the greatest height above the above the floor reached by the ball. Okay, find the greatest height above the floor reached by the ball. A, the first time it rebound from the what? From the floor. The first time it rebound. Okay, so we are going to get the speed of rebound. Okay, because here we are told that it rebound with what? With 3/4 of the speed. So we are going to have the speed of the first rebound. Okay, let's make it is u2, which is what? Which is 3/4. Okay, of what? Of u1. It will rebound with 3/4 of the speed with which it strikes the floor. So the speed of striking the floor is 14 meters per second. Okay, the speed of striking the floor is 14. Okay, so the speed of first rebound, the speed of first rebound, x is 10 meters. So okay, the speed of first rebound is so we have this, and that's 3/4 times 14. 2 here 2, 2 here 7. That's 21/2. meter per second. That is speed of the force rebound. The first time it rebound from the what? From the floor. The height for the first time it rebound from the floor. Okay, so U is what? Our U is 10.5. What again we have? Okay, if it's rebound, A is minus G. Okay, A is minus G. So please, as you are coming in, just begin to say I. As you are coming in, just begin to say I. If you are new on the channel, please subscribe to the channel and begin to share the links across your different platforms. We have B is equal to 0. Okay, that's at the peak of that rebound. B is 0. Then we can use this equation v square, u square plus 2ax. Okay, so that will be 0 equal to what? U square, that's 10.5 square plus 2 times 9.8. Okay, then my 9.8 is what? For the is vertically upward, so this will become negative. Okay, and then times the height we are looking for. Okay, so that will be equal to x will be equal to 10.5 square over 2 times 9.8, that's 19.6. Then you can punch a calculator meter. That's the height for the force rebound. Before the ball strike before the ball strike the floor for the second time. Its speed 10.5. Then the speed of the second rebound is, let's make it u3. Let u3 be speed of the second rebound. Okay, let it be that u3. Let it be speed of the second rebound. Okay, and we are told is what? 3/4 of what? Of the speed to strike the ground. That's 3/4. So we have this. If we follow the instruction, that will be 7.875. Okay, meter per seconds. So that's what we have there. So then find the maximum height, h2. Find the maximum height. We find out. We got. Let's get the maximum height. Which is h2. Let's make it h2. Okay, h2 reach after second rebound. So we have u as 7.875 meter per second. Okay, we have the final velocity at 0. Okay, when it rebound, once you rebound at the maximum height, final velocity is 0. Okay, acceleration is negative. It's against gravity, minus 9.8. That's is equal to g minus 9.8. That's the acceleration. Then our x is h2. This equation again, u square plus 2ax. My v is 0. My u is 7.875 square plus, that will be minus 2 times 9.8 plus my a is minus g. And then times what? Times x. So final conclusion, the maximum height for the second rebound, that will be 7.875 square over what? Over 19.6. Okay, so if you do that, you are going to get 3.164 meter. Okay, take a short break.